So, this is the second part of the lecture, value engineering methodology. So, we were discussing the function phase. These things are discussed. We were discussing the function phase, wherein we have defined what is function, and we were on the fast diagram, that is function analysis and system technique. So, what is function analysis and system technique? Function analysis system technique aids in thinking about the problem objectively, that is, it identifies the scope of the project by showing the logical relationships between the functions. So, what we did in the previous phase or previous part of this phase, function phase, we identified the functions, we divided the functions into two categories, primary function and secondary function. The primary functions were the main functions for which the product was made. Secondary functions may be some work functions or maybe some self functions as well, for which the product is being sold, or some functions which are not directly visible. Some functions, for example, if I took this example of this mobile, the interior integrated circuits here, the integrated circuits in the mobile are not seen, but those are work functions, those are required to work. So, some of those components are not for primary use, they are just in the product to make the product work. For example, if I need to take the picture or take the snap from my mobile, I will just click the camera button there and the picture would be ready. Okay. So, what is making this work? There is an integrated circuit, and there might be some other supporting circuits which are helping that to work. Those are secondary functions, but also work functions. So, what are the relationship between the functions which we have defined previously that this fast diagram would tell us? So, the organization of functions into function logic, this is fast diagram. It enables the participants to identify all the necessary and unnecessary functions. So, necessary function would come into the critical path. We will have a critical path or critical design path that our diagram would follow. Those functions would be necessary. Some of the functions which are not in the critical path, they would be necessary, and some of the function might be unnecessary, which might be eliminated or may be reduced. The number of these functions can be reduced. So, fast diagram can be used to verify if and illustrate how a proposed solution achieves the needs of the project. So, it identify unnecessary, duplicated, or maybe some missing functions. Missing functions, these are all functions. So, how does fast diagram work? So, this is a kind of a layout of our functions, layout that is used in the fast diagram. We have the function on this side, that is the higher order function. We have the highest order function here. And we see how this function would be accomplished. When we move on this direction, we will see how the function A is being accomplished by using function B, and B is being accomplished by using function C. And also, when you are working on B function, this is when. So, when the function B is being carried out, this function D is also needs to be done. We will see with this with an example. So, these are called as lower order function. This is how do you, this is why do you. So, I say I need to make a call. Highest order function is make a or make call. So, we will have put here design mobile phone. How to make a call? Design mobile phone. How to design the mobile phone? Design components. How do we design components? Get specifications, component specifications. Okay, so this is how we are doing, and here on this direction we are moving towards why. Why do we need design specifications? Because we need to design the components here. And why do we need to design components? Because we need to have the mobile phone. I'm just taking a very broad example here. So this also has a scope of study. This is our scope of study, it is mentioned here. The where function, active function is an active verb and measurable noun. So this would be kind of a critical path. This might not be, this function might not be the part of our critical path. So we have the lowest order function here. So lowest order function is the lowest function, that is the start of the product here. So let us see the steps here, how to make, how to draw, how to analyze our functions and make the function analysis system technique diagram. First step is determine the highest order function. This is the objective of value study, that is the highest order function. This is located in the left basic line here, highest order function. Then we identify the basic functions. The basic functions are the functions for which the product is designed, that is how does the product or process perform the highest order function, that is how would this function be accomplished, function A be accomplished. Function B is my, again the basic functions, one of the basic function, but not the primary function. Okay, this might or might not be the primary function. Then expand the fast diagram. Once we have identified the primary functions, that is function A, B, C, we will expand it to functions D, E, F, so on, and using this when logic, that when function D is to be there. This is our critical path, A, B, C is our critical path here. Then we identify the supporting functions, that is the function D, kind of function D here. Supporting function do not depend on another function. This is not connected here. Function D, if you see, this is a connecting line here. This green line is a connecting line here. But function D is not connected. So these support functions do not connect. So any unnecessary function can be the only support functions. The primary or basic functions cannot be the unnecessary functions here. This is very important point, please make a note. The unnecessary function can only be a support function. So then we verify the fast diagram. So what happens once we have made the fast diagram, sometimes this support function which D, we can think of it is working with B, it might work with C, we can keep changing. It is better to use the slips, write the name of the function on the slip and keep arranging the slips in the order, and then you will see the various alternatives. Okay, this is the right position where the slip 2 has to be put, and we will just verify the fast diagram that is the critical path right or not. So I will construct a fast diagram for pen here. I have taken pen as an example here. So what is the basic function of the pen? Write notes. Okay. Then why do we write notes? Is there a question? So is there a higher order function here? Actually this function or the primary function, I am trying to identify the highest order function. Is there a why that is existing? Why do we write notes? Yes, we need to record information. Okay, do the pen only write notes? It also make marks. Make marks. Here marks means make lines, that is make sketches. So write notes and make sketches are the both things the pen is doing. So Could we have a single function that define both these things? Yes, make marks can be one thing that involves both write notes and make sketches. So record information is a kind of my highest order function. So why do we record information? We need to provide information to somebody. Let me put the highest order function here is provide information. Then I will draw a scope line here. This is my highest order function of a general pen. So this is my pen. I have this cap. Let me see the product. I have this cap. This is the pen. It has a refill in it. It has a grip that holds this one. This cap secures the nib or tip so as accidentally no mark is made. And this body is securing the refill. This refill is securing the ink. The ink is used to make the marks. The nib is using the ink to make the marks. So these are all the components here. These components I have broadly discussed in the previous lecture as well. So let me try to make the fast diagram here. So how do we provide information? We record data. And how do we record data? We are moving towards this side, that is how. This is my how on this side. Then how do we record data? Make marks. Okay. So how the marks are being made? So how is this pen working? How the marks are being made on the paper? So that is using ink to make the marks. Using ink. So let me put it in a better way. Deposit ink. Yeah, this would be a good verb here. Deposit ink. And how do we deposit ink when we write? We apply some pressure or some load on the pen when we write. So I could write here hold pen, or I could write apply pressure. So when the pressure is here, we can also put the function here transmit force. How do we apply pressure? We transmit force, a little force on the pen so as the pen is able to write. A little pressure. Okay. So it is transmitting force here. So this is a simple pen. Transmit force, this body is used. This size of the pen, as I have mentioned before, this is between 7 to, this is approximately 8 or 8 to 10 mm is the diameter of this grip here. So this is the grip, this body is there, that is helping to transmit force here. We are holding this body here, refill is in it here. So what is the body doing? It is also protecting the refill inside. So I can write a function here, how function, that is provide or support refill. So I think I need to mention the refill before here. See, when you will draw the fast diagram, you will do number of iterations. I am also trying of putting the function and rubbing. So this iteration will happen. So when you try to do this, actually I have read the fast diagram for pencil, that is by NPD Solutions. NPD Solution is the website. That is New Product Development Solution. It is by DRM Associates. So that is fast for pencil. Fast diagram for pencil. So, I am trying to adapt that way, that same diagram, to draw the fast diagram for this pen. So, I was talking about the refill here. So, transmit force, we need to we have the body is there, that is transmitting force. Also we need to, I can put it here, not on the right side, parallelly we need to support ink as well. And support ink is done by provide refill. When we provide refill, refill also has tip in it. So, I can say secure tip. Secure tip is helping to deposit ink as well. So, this will be connected. We will make the connections. So, next, provide refill. Refill is supported by the main body. So, that is done by support refill. So, we are recording the data, we are making marks. How do we record data? We make marks. How do we make marks? We deposit the ink. How do we deposit ink? We apply pressure. How do we apply pressure? We transmit force. This transmit force is actually done by our support refill is one function, that is our body. I can write it in a different color here. This is actually my body, which is helping to support refill and transmit force as well. Also we can see we have this grip over this body. So, purpose of this grip is to make the user hold the pen properly, so that the pen does not slips. So, with support refill, I can also say here provide grip. So, this is one of the function. So, I think there are other functions like aesthetics, provide aesthetics to the pen, provide information, that is the company name here, Cello Butterflow pen. So, all these things can go to the support functions. So, this is on the body only. So, I can write it here, provide aesthetics, and the company name I can write provide identification. So, these two are my support functions. So, I think I can draw the scope line here, and these are the support functions. Support ink cannot be a support function, it is a basic function only. We will see how does it come into our critical path. So, we provide grip here, and finally we can hold the pen. So, let me connect this, record data by making marks, by depositing ink, by applying pressure, by transmitting force. Transmitting force is done by support refill, and apply pressure is done by this support refill transmit force. This is also connected here. I will connect this thing because this is not a support function only. Support refill is, again we need to provide refill, and secure tip. Secure tip, I can divide this into further components. How do we secure tip? In this case, we also need to protect tip as well from breakage. Okay, that comes in secure tip only. So, this is done by using, in this case we are using this cap here. The cap is used to protect my tip. So let me put provide cap. This is not connected in the critical path, but this is just to secure tip here. Provide cap, we can provide cap, we can have some click type of pen, the pen that is clicked from the back, click, that is provide button, that button makes the tips to come out and to go in again. So also there is a kind of a pen, I have this pen in which the tip comes out and go in by using this nut and bolt mechanism here. So this is nut and bolt mechanism. So if you know the nut and bolt mechanism, nut and bolt is, this is also kind of a nut. This back support is also kind of a nut. So when I rotate this, it goes, it screws in, it screws out. So this nut and bolt mechanism is used to secure or to protect this tip. Okay. So I can write these other alternatives here, provide cap, provide nut, and maybe provide button. Okay, these are the functions which are helping to secure the tip. Finally, we will hold a pen. So let me enclose these into the boxes here. And these are linked. Any alternative can be used. So this is my fast diagram of a normal pen. Okay. So my scope of study is here. This is my scope of study. Study means scope of value engineering study here, in which I need to find the functions on which I need to work on, what are the poor value and high value functions. We are having how on this side and when on this side. So there are various functions like support, refill. If we see this support refill function, so this is not only carried by this body. I have put this body in bracket here. This is a component, not a function. But this support refill is actually done by three components here. It is the body here, this is the refill, it is the back nut that is helping the refill to keep inside, and it is the front nut. So these three components would have this function, support refill. Okay. So also this function, the color of this back nut is blue, the color of this front nut is silver. These are static functions, these are secondary functions. These would have the primary functions to support refill, and the secondary functions would be provide statics. So this is my fast diagramming of a pen. So there is no correct or perfect fast diagram. So one can even choose different names here. For example, if this is provide identification, one can say, okay, I'll display information, kind of. Provide statics can be enhance statics or enhance appearance. The verb and noun should mean the same thing. The word you choose doesn't matter here. So this is a normal pen. So let us try to extend this diagram to other kinds of pen, that is the multifunctional pen. I have carried a few kinds of pens here. So this is a pen that has multiple colors. It has blue color, it has blue, green, red and black color in it. So these are also two other kinds of pens. So this is a pen that is also doing the stylus function. The back side of this pen, actually the secure tip function is carried out by this nut and bolt mechanism, and this back can be used to work as a stylus on the mobile. I can doodle on my mobile. Okay. So Let me think of a pen that even it is having different refills, okay, there are different colors that we can choose, and also it has this stylus function over, this rubber over here, okay. So, how to see, I am having two kinds of stylus here. One pen is having the stylus at the back. I can keep writing the notes and work on the stylus on my mobile. This is one way. Second way is, this is a back button click pen in which I can keep writing notes and switch this button off, and on the front only I have this capacitive stylus here. There are two ways to do that, okay. They have chosen different ways, different companies. So, what is the way to provide this function here that we can see, that we can put in the function, that this is actually a kind of the alternatives in the function analysis. We will just put here in this kind of pen, we can change color of the refill, okay. So, where to put this change color? When I am transmitting force or when I am applying pressure, I can put change color here, okay. Change color, that is only done by clicking thing only here, okay, by clicking by this switch only. So, also if it is a stylus here, I can switch mode, write the pen with this one, switch to stylus. So, this is switching mode by clicking, writing the notes, switching to the stylus. So, this switch mode, in this also I am actually applying pressure, this can also come here. Switch mode, do I put it, I will put it here only with apply pressure. Switch mode, that is switch mode is switching from the ink to stylus, to the capacitive stylus. So, this switching mode can happen in two ways. We just provide it at the back, that is provide nut security tip, this can be connected here. Switch mode can be done by provide button. So, let me use a different color here, because this is a provide button, and maybe by provide nut. This change color and apply pressure, this is my critical path. Critical path, I will put again a different color, let me choose this one. This is the critical path. Critical path means it has all the basic functions. This should also come in the critical path. So, I think this support ink is also required. Provide refill, secure tip, choose any one of these part, and this would be connected here, okay. So, I am going in the other direction now, changing color. Why do we change color? Because we need different colors. And why do we switch mode here? Because we need to have this stylus. I can write here secure or secure stylus can be right word here. Secure stylus, okay. And why do we secure stylus? Because we need to doodle on the form, or we need to again record data. If not recording, we need to collect some information. Okay, these are again the higher order functions. In this way, we can construct fast diagram for any product we like. Change color is something that is connected to the upper part only, and this lower part is the multifunctional. So, this is my fast diagram of multifunctional pen. Multifunctional pen means it has stylus in it and it has different ink colors. So, not to forget, this is a when logic. When do we change the color? When we need to apply pressure, when we need to write something, we need to deposit ink, we need to change the color. And when do we switch mode? When we need to apply pressure on the mobile, on my touch screen or interactive tablet or laptop here. Okay, so this is when logic here. So this is the fast diagram of a pen which I have tried to make. So you can even choose to make a different diagram, different locations, but the basic layout would be same here. So let us move forward. Is there a correct fast diagram? There is no correct fast diagram, but there is a valid method of representing the logic in a diagram. The way I said, I can choose to put support refill on the function on the left or right side. It can vary, but the basic logic, the layout of the functions is there. Okay, the basic logic would remain same. Okay, the validity of a fast model for a given situation is dependent on the knowledge and scope of the workshop participants. It is my knowledge that is trying to build this fast diagram. Okay, if a team comes, they can say some different way to do this. The fast diagram aids the team in reaching the consensus on their understanding of the project. So when they doodle on this thing, when they work on different alternatives, where to put this or where to put not, they are working on the project. They are trying to bring the ideas. They are working on the final product in a way here. So in that way, they come to a consensus here. Okay, this is a right fast diagram, and they are understanding spearheads to a single goal. Single goal or target. So this is something the team would enjoy, and their engineering skills would also work here. So let us meet in the next lecture. Thank you.